At 11:55 p.m. in Sevastopol Bay, a column of fire rose dozens of feet above the dark water as Russia's Project 11356R frigate, Admiral Gregorovich, was struck on its starboard side. Within minutes, the nearly 4,000-ton warship began listing approximately 11 degrees. According to the sequence of events reconstructed from operational details, the impact followed a coordinated maritime drone operation launched from the direction of Odessa approximately 51 minutes earlier. The Admiral Gregorovich, a 407-foot guided missile frigate valued at roughly $650 million, is one of the Russian Navy's key platforms in the Black Sea. It carries 8 vertical launch tubes armed with caliber NK cruise missiles with a range of about 2,500 kilometers, as well as the Shtil-1 air defense system equipped with 24 Buk missiles. The vessel is among the few remaining ships capable of launching long-range cruise missile strikes deep into Ukrainian territory. At the time of the incident, the ship was positioned inside the heavily guarded harbor of Sevastopol in Crimea, considered one of the most protected naval facilities in the region. The attack involved 5 unmanned surface vehicles identified as Mura 55 craft. Each vessel weighs approximately 2,200 pounds, carries a 320-kilogram warhead, and is capable of reaching speeds up to 42 knots with an operational range of roughly 280 miles. Designed with a shallow draft of about 16 inches, the craft operate close to the surface, reducing their detectability by conventional harbor sonar systems. Each unit is estimated to cost around $250,000, a fraction of the value of the target they approached. At approximately 11:05 p.m., 31 nautical miles southwest of the entrance to Sevastopol Bay, operators in Odessa monitored the 5 drones on night vision screens. The craft did not travel in a tight formation. Instead, they dispersed across nearly 5 square miles of water, offset 10 to 12 degrees from a direct approach line to avoid forming a pattern that could trigger automated radar recognition systems. Russian coastal radar systems, including maritime surveillance units calibrated to detect objects with a radar cross-section of approximately 0.1 square meters or greater, form the outer defensive layer. The Mura craft, when operating at maximum power, fluctuate near that detection threshold. To further reduce their radar signature, the drones slowed to approximately 14 miles per hour. At reduced speed, their hulls sat deeper in the water by nearly 6 inches, minimizing bow wave and wake and lowering their radar cross-section to an estimated 0.04 to 0.06 square meters. In such conditions, radar returns could resemble floating debris or buoys, objects unlikely to trigger immediate escalation during routine night watch operations. Beyond radar surveillance, Sevastopol Bay was protected by a multi-layered defense system. At the bay entrance, an anti-intrusion boom stretched from shore to shore. This barrier consisted of steel floats linked to a submerged cable net with mesh openings of approximately 31 inches, extending nearly 20 feet below the surface. Its purpose was to entangle incoming craft and prevent high-speed penetration into the harbor. Overhead, a Ka-27 helicopter conducted continuous patrols in loops approximately 5 miles in diameter, each cycle lasting 14 minutes. Equipped with forward-looking infrared systems capable of detecting small thermal anomalies against 46° Fahrenheit water, the aircraft represented an additional detection layer. Finally, the frigate itself was equipped with close-in defensive gun systems featuring twin 6-barrel mounts capable of firing 5,000 rounds per minute, designed to engage threats within a range of about 2.5 miles. At 11:22 p.m., as the drones closed the distance, mission oversight in Odessa focused on synchronizing multiple vectors of approach. The strategy did not rely on overwhelming speed, but on distributing attention across several ambiguous contacts, forcing defensive personnel to assess multiple simultaneous signals during late-night watch conditions. By 11:41 p.m., 2 of the drones altered course and increased power slightly, raising their radar and thermal profiles enough to draw attention. Russian coastal operators detected movement from the southwest. The Ka-27 helicopter adjusted its patrol, and the anti-intrusion boom system was positioned to intercept. The 2 drones maintained course and deliberately impacted the submerged steel net. Their propulsors became entangled, and both craft were immobilized at the bay threshold without detonating their warheads. Russian command reported the 2 targets neutralized at the entrance. The immediate assessment indicated that the defensive system had functioned as intended, preventing penetration into the harbor. At that moment, the situation was believed to be under control. However, 3 additional drones remained in operation beyond the outer detection focus. As attention concentrated on the immobilized craft, the remaining units maneuvered toward a maintenance opening in the boom line. The broader sequence of events would unfold in the minutes that followed, culminating in the impact on Admiral Gregorovich shortly before midnight. The incident marks a significant development in the use of low-cost unmanned surface systems against high-value naval assets within fortified harbors. Further details on the engagement, defensive response, and resulting damage will be examined in Part 2. At 11:43 p.m., while attention remained focused on the 2 immobilized unmanned surface vehicles at the entrance to Sevastopol Bay, 3 additional craft continued their approach. The Ka-27 helicopter entered its 7th patrol loop of the night, maintaining a 5-mile circular pattern over the bay mouth. On board, the forward-looking infrared system registered 3 small heat signatures moving irregularly from the southwest. The contacts were low to the waterline and steady in motion. According to operational details, similar thermal signals had appeared in the same area on 11 separate nights during the previous 3 weeks. Those earlier detections involved modified commercial craft carrying no warheads and were intercepted without escalation. As a result, repeated experience with non-lethal contacts formed part of the operational background in which the new signals were assessed. The helicopter descended several dozen feet to improve visual confirmation. A searchlight swept across the surface of the water, and rotor wash disturbed the waves below. One of the 3 approaching craft reduced speed significantly, lowering its thermal output and blending closer to the surrounding water temperature. The other 2 shifted slightly outward from the helicopter's sweep axis while maintaining course. A dipping sonar was deployed briefly and then retracted. Communications between the helicopter crew and shore command consisted of short confirmation exchanges. Nearly 1 minute elapsed during this evaluation cycle. During that interval, the 3 remaining craft reached a known maintenance opening in the anti-intrusion boom system. The opening had been observed and tracked in advance. Rather than accelerating, the unmanned vessels proceeded at low speed, passing one by one through the gap only a few feet from the submerged steel net. By the time the helicopter repositioned for another pass, all 3 had entered Sevastopol Bay. The defensive system continued functioning. 2 craft remained entangled at the entrance, and aerial patrols persisted overhead. However, the presence of multiple simultaneous contacts required allocation of attention across different sectors. The 3 penetrating drones were now inside the harbor perimeter. At 11:51 p.m., the remaining craft increased speed in unison. Their electric motors rose in pitch as they accelerated toward the inner harbor. Thin white wakes became visible behind them, marking the end of their low-signature approach phase. Onboard Admiral Gregorovich, automated defensive systems transitioned to engagement mode as the incoming objects entered the inner envelope. At 11:53 p.m., the distance between the lead drone and the frigate dropped below approximately 2,600 feet. The close-in defensive gun system achieved target lock. After a 3-second acquisition cycle, the twin 6-barrel mounts opened fire at a rate of 5,000 rounds per minute. A sustained burst struck one of the craft, identified as Mura No. 4. It detonated more than 1,500 feet off the bow of the ship. Fragments were propelled upward and outward, and the resulting shock wave disturbed the trajectory of the 2 remaining drones. The guns shifted to the next target as the range narrowed to under 2,000 feet. A second burst impacted Mura No. 2 on its starboard side, tearing open the bow section. The damaged craft lost forward momentum and came to a stop amid smoke and reflected firelight on the water surface. 1 drone remained operational. With range decreasing rapidly and now under 1,000 feet, the remaining craft accelerated to full power. The defensive system attempted to re-engage, but the compressed distance limited the available firing cycle time. The closing seconds reduced the engagement window. At 11:55 p.m., the final unmanned surface vehicle struck Admiral Gregorovich on the starboard side at a calculated point beneath the aft auxiliary deck, directly below the reserve ammunition compartment for the AK-100 100mm naval gun. The 320-kilogram warhead detonated upon impact, breaching the hull plating and creating an opening more than 3 feet wide. Initial assessments on board categorized the event as localized damage. The automatic firefighting system activated, deploying water and chemical foam into the affected compartment. Seawater began entering through the breach. However, The explosion had occurred directly beneath stored 100mm ammunition. High-temperature fragments and pressurized gases penetrated the reserve ammunition area. Within minutes, temperatures in the compartment exceeded safe thresholds. Individual shells began to detonate sequentially. The detonations were not simultaneous, but occurred in a series of internal blasts that expanded structural damage. The aft auxiliary deck visibly deformed. Warped metal compromised watertight bulkheads, allowing additional water ingress beyond the initial breach. Approximately 3 minutes after impact, the ship developed a noticeable starboard list as flooding continued. Black smoke emerged from the aft section. Antennas and auxiliary systems experienced vibration and intermittent power fluctuations. Damage control teams attempted containment, but internal heat and structural distortion complicated suppression efforts. 7 minutes after the strike, the captain ordered the aft section sealed. Preparations began to maneuver the vessel toward shallower water inside the bay to prevent loss of stability. Portions of the crew were instructed to abandon sections of the ship temporarily while damage control operations continued. Admiral Gregorovich remained afloat. The anti-flooding systems functioned as designed, preventing immediate catastrophic sinking. However, the aft gun ammunition compartment was destroyed, and structural deformation rendered associated systems inoperable pending inspection. Combat capability was significantly reduced. The 8-caliber launch tubes positioned forward were sealed for safety evaluation following the internal detonations. By the early hours of the morning, emergency response measures included dispatching support vessels and reinforcing harbor security. Naval activity within Sevastopol Bay was suspended for safety checks and procedural review. The incident resulted in the temporary removal of one of the Black Sea Fleet's principal cruise missile platforms from active operational status, with repairs expected to require months depending on the full extent of structural damage. The engagement demonstrated that, despite 3 defensive layers, coastal radar, anti-intrusion boom, and close-in gun systems, a coordinated multi-vector unmanned surface attack was able to penetrate the harbor and inflict critical damage on a high-value naval asset. By the following morning, satellite imagery showed Admiral Gregorovich still afloat inside Sevastopol Bay, listing slightly to starboard. The aft section displayed visible scorching, and dark smoke stains marked the area above the impact point. The vessel's anti-flooding systems had prevented rapid sinking, but external assessment indicated structural deformation around the aft auxiliary deck and damage to the ammunition compartment serving the AK-100 naval gun. Naval engineers began preliminary evaluation of the hull breach, estimated at more than 3 feet in diameter at the point of initial impact. Internal inspections focused on warped bulkheads, compromised watertight compartments, and heat damage resulting from secondary ammunition detonations. According to the sequence of events, individual 100mm shells detonated after temperatures inside the reserve ammunition space exceeded safe thresholds, producing repeated internal blasts that expanded the original damage zone. As a precaution, the 8-caliber cruise missile launch tubes located forward on the ship were sealed pending safety assessment. Although not directly impacted by the explosion, shock transmission through the hull and internal systems required verification before any return to combat readiness. Associated electronic and fire control systems underwent shutdown for diagnostic review. The incident triggered immediate operational adjustments within Sevastopol Bay. Additional tugboats and escort vessels were dispatched to support the damaged frigate. A second boom layer was installed at the harbor entrance, reinforcing the existing anti-intrusion barrier. Patrol patterns for the Ka-27 helicopter were reviewed, and harbor security protocols entered a heightened state. Naval movements were temporarily restricted while safety inspections and procedural analysis were conducted. The attack resulted in the temporary loss of combat capability for one of the Black Sea Fleet's principal cruise missile platforms. Admiral Gregorovich, valued at approximately $650 million and capable of launching caliber cruise missiles with a range of about 2,500 kilometers, represents a significant strategic asset. Its withdrawal from operational status reduces available long-range strike capacity in the region until repairs are completed. Depending on the depth of structural compromise discovered during detailed dry dock inspection, restoration to full readiness could require months. The engagement also underscored the asymmetry between cost and effect. Each Mura 55 unmanned surface vehicle involved in the operation was valued at roughly $250,000 and carried a 320-kilogram warhead. 5 such craft were deployed. 2 were immobilized at the boom barrier without detonating. 2 were destroyed by close-in defensive fire before reaching effective range, and 1 penetrated the final defensive layer and struck the target. The total material investment in the attacking platforms was a fraction of the value of the damaged vessel. From a defensive perspective, all 3 protective layers functioned according to design parameters. Coastal radar systems detected elevated signatures when drones increased output. The anti-intrusion boom successfully stopped 2 incoming craft. The close-in weapon system intercepted and destroyed 2 additional targets within engagement range. However, the coordination of multiple simultaneous vectors forced distribution of attention and firepower, creating a narrow window through which one craft reached the hull. In the broader operational context, the event represents a continuation of maritime drone tactics in the Black Sea. The method combined low radar cross-section, reduced thermal signature, distributed approach geometry, and timed activation designed to saturate human decision cycles during night watch conditions. The operation relied on exploiting small temporal and spatial gaps rather than overwhelming defensive firepower directly. The psychological impact within the fleet is also under assessment. Sevastopol has been considered one of the most heavily guarded harbors in Crimea, protected by layered surveillance and physical barriers. The penetration of those defenses by a low-cost unmanned platform is likely to influence future force protection measures and resource allocation. Naval analysts note that further adjustments may include expanded boom coverage, additional aerial patrols, revised rules of engagement for ambiguous contacts, and technological upgrades to radar filtering algorithms tuned to detect smaller radar cross-sections. Harbor operations are expected to incorporate lessons learned from the sequence of detection, diversion, and final impact. As repair teams continue structural surveys of Admiral Gregorovich, the strategic balance in the Black Sea remains under review. The event demonstrates the operational consequences of unmanned maritime systems against capital ships in confined harbor environments. Both defensive doctrine and offensive planning are expected to evolve in response to the engagement. For continued updates and detailed analysis of developments in the Black Sea region, subscribe to our channel.